Language models of code are future planners and reasoners for multi-doc summarization with attribution. This work is done by me, Abhilash, as an intern and Sambaran at Adobe, and this is accepted at AAA 2025.
Hear me out. Now, suppose you are writing a research paper and you have a bunch of reference papers, abstracts, and you have already written the abstract of the research paper that you're writing. And now you want to automatically generate the related work section of the same paper because, frankly, it is very tedious and it would be a great help if that was automated. Now, our research does a deep dive on that, like how to improve automatic generation of the related work section and framing it as a multi-document summarization problem. Now, you might say that you will feed everything into ChatGPT and ask it to generate the related work section. But the problem with that is the related work section of any research paper contains references to other research papers. Now, these are inputs in our framework. However, the way in which these references are grouped adjacent to each other and in a sentence is something that ChatGPT does not necessarily focus on directly. Also, the text that is adjacent to these references and is relevant to these references is something that is very important for a related work section, the relevance. But that is again not captured by ChatGPT necessarily. There is where we come in. We divide the task of multi-document summarization into two stages. In the first stage, we take the help of an LLM that is good at generating code, say ChatGPT or GitHub Copilot. And what we do is taking all the input reference abstracts as well as the query abstract that we have written. We ask the LLM to basically generate this layout of references, that is how the references would be grouped, whether a bunch of references or citations in the final summary will be adjacent to each other in the same citation bracket, or whether they'll be in the same sentence but not in the same bracket, or whether they'll be in completely different sentences. So this kind of hierarchy of grouping of the references is basically represented in the form of a nested dictionary. Also, we have to ensure that the text surrounding these references are relevant to the references as such. For that, we ask the LLM to also generate certain topics or say entities that are relevant to these citations or references that occur in a single sentence. The code is generated in an in-context learning setting where a bunch of example input-output pairs are given in the input prompt itself to guide the LLM to generate the output in a particular format. The in-context examples are selected using a trained graph attention network, which basically ensures that the in-context examples are similar in nature and meaning to the example for which we want to generate the summary. Now, in the final stage of summarization, what we do is the generated code is appended to the input reference abstracts and the query paper abstract, and then we ask ChatGPT or any LLM to basically generate the final summary based on all this information. We have seen that this improves the performance across LLMs by a large margin. Stay tuned for more updates on this work, and ciao for now.